Your AI coding agent is not as smart as you think, and it is not as dumb as it looks either. Most of the time, the difference is the repo. Same model, same prompt, same coding tool. One codebase makes it look like a senior engineer. Another codebase makes it wander around for 10 minutes, change the wrong file, invent a config option, and then proudly tell you the task is done. That is not magic. That is environment design. Coding agents do not just reason in the abstract. They read your files, they copy your patterns, they run your scripts, they trust your names, they follow the path of least resistance through whatever mess you gave them. So if your repo is vague, hidden, inconsistent, and impossible to verify, the agent behaves vaguely. If your repo is explicit, small, searchable, and easy to test, the same agent suddenly looks much smarter. This video is about 10 repo patterns that make coding agents less stupid. Not better prompts, not a new subscription, not one more model picker, the actual shape of the codebase. Because the uncomfortable truth is this: a coding agent is only partly using the model, the rest of it is using your repo as its brain. Hey, don't forget to like and subscribe for more like this. Now, back to the video. Number 10 is one obvious command for every common job. This sounds boring. It is not boring. It is one of the biggest differences between an agent that works and an agent that guesses. A human developer can ask around. They can remember that the front end uses p-npm, the back end uses npm, the test only passed if the database is running, and the link command is secretly called quality. An agent cannot remember office folklore. It needs discoverable commands. If the repo has one clear script for tests, one clear script for type checking, one clear script for linting, one clear script for running the app, and one clear setup path, the agent can verify its own work. If those commands are missing, the agent starts improvising. It runs npm test in a p-npm repo. It installs packages you did not want. It runs the wrong test suite. It gives up after a command fails once or worse. It stops testing entirely and explains why the change should work. That is when AI coding turns into theater. The fix is simple. Every repo should have a small command surface. Install, run, test, check, format, build. Those names should work from the obvious place. If the repo is a monorepo, there should still be a top-level way to discover the right package command. The agent should not need to inspect 5 package files to learn how to run one test. This matters because verification is where agents become useful. A model that can edit but cannot check is just a very confident intern with write access. Give it commands that work, and suddenly it can loop, change run, read the failure, change again. That loop is the product, not the chat box. The loop number 9 is small files with boring names. Agents are much better when the codebase has obvious boundaries. Humans complain about giant files because they are hard to read. Agents have a different problem. Giant files make every task look connected to every other task. If one file contains routing, validation, database access, state management, UI logic, permissions, formatting helpers, and 3 abandoned experiments, the agent has no clean place to cut. It sees everything at once, so it touches too much. Small files are not about aesthetic purity, they are about reducing the blast radius of automated edits. A file called invoicetotals.cs tells the agent something useful. A file called utils.c tells it almost nothing. A folder called billing is useful. A folder called misc is a junk drawer with a sign on it. When names are clear, the agent can find the right area faster. When names are vague, it has to infer intent from implementation. That costs context, it costs time, and it increases the odds that the edit lands in a place nobody meant to touch. This is why coding agents love boring structure. They do not need clever file names, they need searchable ones. Use the words a developer would type when they are looking for the thing: auth, billing, checkout, webhook, permissions, email, upload, cache, queue. The less poetic the repo is, the better the agent gets. Number 8 is examples next to the code. Agents copy local patterns aggressively. That is good when the local pattern is it is terrible when the local pattern is accidental. If your repo has one clean example of how to add a route, the agent can follow it. If your repo has 5 different route styles, the agent will pick one at random and justify it with confidence. Examples are not just documentation. They are training data inside your own project. Every time the agent asks, how do people do this here? The repo answers. So give it answers that are close to where the work happens. A test file that shows the right mock style, a component that shows the right loading state, a handler that shows the right error response, a migration that shows the right naming convention, a small feature that acts as a template for the next feature. The key is proximity. Do not hide the pattern in a wiki page from 2 years ago. Do not expect the agent to read the whole history of the project. Put the living example near the thing it needs to change. This is also why bad examples are dangerous. If there is an old test that skips the hard assertion, the agent may copy that. If there is a component that catches every error and returns null, the agent may copy that. If there is an endpoint that forgets authorization, the agent may copy that. The agent is not asking which pattern you wish the repo used, it is asking which pattern the repo appears to use. Clean one example before you ask it to create 10 more. Number 7 is tests that fail for the right reason. The dream is not that agents write perfect code in one shot. The dream is that agents can tell when they are wrong. That requires tests with useful failure signals. A bad test suite turns the agent into a gambler. Something failed. Maybe the code is wrong. Maybe the fixture is stale. Maybe the database is missing. Maybe time zones changed. Maybe the snapshot is enormous. Maybe the test depends on order. The agent now has to debug the test suite before it can debug the feature. Good tests narrow the problem. They fail close to the bug. They name the behavior. They avoid giant snapshots unless the snapshot is truly the product. They separate setup failure from logic failure. They do not require tribal knowledge to run. For agents, a test is more than a safety net. It is a steering wheel. When the test failure says expected admin users to see 3 invoices, receive 2, the agent has a target. When the failure says snapshot did not match, and the diff is 1,000 lines of generated HTML, the agent has a fog machine. If you want better AI coding, improve the failure messages. That sounds tiny. It is huge. Agents follow error output, the way humans follow signs in an airport. If the signs are bad, they still move. They just move in the wrong direction. Number 6 is one source of truth for project rules. Most repos have rules scattered everywhere. Some in the README, some in a style guide, some in old pull request comments, some in a senior developer's head, some encoded in lint, some only discovered after production breaks. An agent cannot follow rules it cannot find, so create a small explicit project instruction file, not a novel, not a motivational speech, just the rules that matter every time. Use this package manager. Do not edit generated files. Run this check before finishing. Do not change migrations without approval. Keep UI components away from database imports. Prefer existing helpers before adding new ones. When touching payments, run this specific test file. Those are useful words like clean, elegant, modern, robust, careful, and best practice are not rules. They are vibes wearing a tie. Agents need concrete boundaries. The best project rules are short enough that the model actually pays attention to them. If your instruction file is 5,000 words, most of it is probably guilt. Make it smaller, make it sharper, make it easier to obey. The agent should not start every task by reading the company constitution. It should start with a handful of rails that stop the common crashes. Number 5 is typed boundaries. This is where programming languages matter. AI can write JavaScript. AI can also hallucinate what a JavaScript object looks like and get away with it until runtime. Types are not just for humans. Types are feedback for agents. A strong type boundary tells the agent what shape is allowed. It turns vague intent into a contract. If the agent passes UID as a number when the rest of the system expects a string, the type checker catches it. If it forgets a required field, the type checker catches it. If it imports a server-only type into client code, a good setup can catch it. This is one reason agents often feel better in repos with TypeScript, Rust, Go, or well-typed Python than in loose projects where everything is a bag of whatever. The model may still make mistakes, but the repo argues back. That is what you want. A repo that politely accepts nonsense is bad for AI. It lets the agent drift. A repo with typed boundaries creates friction exactly where friction helps. Do not think of types as ceremony. Think of them as guardrails that the agent can bounce off before you have to review the code yourself. And this applies beyond languages. Database schemas are types, API contracts are types, validation schemas are types, config schemas are types. The more the repo can say no automatically, the less you have to babysit. Number 4 is generated code that is clearly marked. Agents are very good at editing the wrong thing. Generated files are one of the easiest traps. A human sees a giant generated client and thinks, do not touch that. An agent sees a file with the exact function name it was searching for and thinks, perfect, found it. Then it edits the generated file. The test passed for 5 minutes. The next generation command wipes the change, or the build fails in a weird place, or the human reviewer has to explain that this file was never meant to be edited. Mark generated code loudly, put generated folders in obvious places, use file headers where appropriate, add generated paths to project instructions, make the generation command easy to find. Better still, make the source file easier to find than the output file. If the real schema lives in one place and the generated client lives in another, the agent needs to know which one is the lever and which one is the shadow. This pattern is not glamorous, but it prevents one of the most common forms of fake progress. The agent changes what looks like the code. The repo later reveals it changed the wrong layer. That is exactly the kind of stupidity a repo can prevent. Number 3 is clear ownership around risky areas. Not all files are equal. Changing a button color is not the same as changing auth. Changing a test helper is not the same as changing billing. Changing a README is not the same as changing database migrations. But many repos present every file to the agent as if the risk is the same. That is a mistake. Risky areas need labels. Auth, payments, permissions, encryption, data deletion, migrations, infrastructure, deployment. If an agent enters those areas, the workflow should change. Maybe it must ask before editing. Maybe it must run a stronger test suite. Maybe it must explain the security assumption. Maybe it must avoid automatic fixes and only propose a plan. The point is not to make agents timid. The point is to make them context aware. A good human developer changes behavior when the risk goes up. A good repo teaches the agent to do the same. Without that, the agent may treat a checkout permission check like a CSS class, and that is how you get code that looks clean and fails where it matters. Number 2 is short tasks with a visible done condition. This is partly repo design and partly how work is written inside the repo. Agents do much better when tasks have a checkable finish line. Bad task, improve the dashboard. Better task, add empty state copy to the invoice dashboard when the API returns an empty list. Bad task, clean up auth. Better task, move password reset, token, expiry into one helper and add tests for expired and valid tokens. The difference is not just clarity. The better task gives the agent a way to know when to stop. Long, vague tasks cause wandering. The agent starts in one file, then notices a related issue, then changes a helper, then updates a test, then refactors naming, then breaks a thing you did not ask about. That is not always because the model is reckless. Sometimes a task had no edge. Repos can help by having issues, tests, and project notes that define small units of work, one behavior, one failing test, one package, one command to verify. This does not mean agents cannot handle large work. It means large work should be decomposed into small jobs with explicit gates. If you want a coding agent to act less stupid, stop handing it clouds and asking for architecture. Give it a door, a key, and a lock that clicks when it is done. Number 1 is a repo that can reject bad code without you. This is the whole game. A coding agent gets smarter when the environment closes the loop. Formatting rejects messy edits. Lint rejects banned patterns. Types reject bad shapes. Tests reject broken behavior. Security checks reject dangerous dependencies. Builds reject missing files. Review rules reject risky areas. The agent does not need to be trusted blindly if the repo can push back. That is why the best AI coding setup is not a better chat prompt. It is a better feedback system. The repo should make wrong moves loud and early. It should make right moves easy to verify. It should expose the commands that matter. It should label dangerous areas. It should keep examples close to the work. It should avoid giant mystery files. It should tell the agent where the finish line is. Then the same model that looked random starts looking useful. Not because it became smarter overnight, because the codebase stopped asking it to guess. So if your coding agent feels stupid, do not immediately buy a bigger model. Look at the repo first. Can it find the right command? Can it identify the right file? Can it copy a good example? Can it run a test that fails clearly? Can it see the project rules? Can the type system catch it? Can it avoid generated code? Can it tell which files are dangerous? Can it stop when the task is done? Can the repo reject bad code without you reading every line? That is the real checklist. AI coding is not just model quality, it is repo quality. And the teams that understand that are going to get much more value from the same tools everyone else is complaining about, because the agent is not just reading your prompt, it is reading your engineering culture. And sometimes the stupid thing in the loop is not the AI, it is a repo that taught it how to behave.